Alrighty, so number 5. Projectile's horizontal range is equal to 8.5 times its maximum height. What is its angle of projection? Right away I'm thinking, why don't I, instead of working with its horizontal range, why don't I work with half of its horizontal range? Because then its horizontal range and its maximum height, I'm talking about one single time, rather than they happen at separate times. Right, wouldn't the maximum height happen halfway through the time, and half the horizontal range would happen halfway through the time, right? So I'm gonna start off with, I'm gonna work at halfway is what I'm gonna call it, and so my y, my s and the y will be maximum, and my s and the x will be half max, right? So I'm thinking, let's see, we got this, right? That's my v initial. This is my theta. And this would be v initial cosine theta. And this would be v initial sine theta, right? My x and my y. I know that at this point, my vy is going to equal 0 meters per second. And so here, I'm going to have horizontal range is 8.5 times maximum height. So here, at this point, I have sy equals 4.25, or actually, yes. Sx, is that right? No, not, sorry. 2 times it's 17 Sx, right? Because Sx is half of my total range, so 17 times half is the same as 8.5 times the whole. Weird way to say that, but if this is x and this is y, if x equals 8.5 y, yep, I wrote this wrong. If x equals 8.5 y, right? Okay, then half of x equals 4.25 y. So sy, 4.25 s of y equals s of x up here. That's my value. What's your value? So yours would be 2.5. Yeah. Yep. All right. And so at this point, at the peak here, sorry for that. The x, or s of x, is going to equal vi cosine theta times t. And the way I think of the y, I still want it in terms, the y will be sy will equal vi sine theta t minus 1/2 g t squared, right? I run into the slight problem of, I've got like 4 unknowns in here and only 2 equations. Oh, wait a minute. I know how Sx and xy are related, so that brings me a 3rd equation. A 4th equation would be nice in here, though, and that's why I kind of picked halfway, because I can say that v in the y direction equals v initial in the y, so vi sine theta plus minus at, which is gt, and I know that that equals 0. So at this point, vi sine theta equals gt. You know, v final equals v initial plus at. All right. So I could substitute that in, and that would bring out get out through one of my thetas. What is? I might want to keep theta in there, though. Yeah, that's why I might want to keep theta in there. So right now I have 4 equations. 1, 2, 3, and 4. And so 4 equations, 1, 2, 3, 4 unknowns, right? So mathematically, that makes me happy because, hey, it's solvable mathematically, right? 4 unknowns, actually 5 unknowns, isn't it? Sx and xy. We'll see. We'll see. So I would like to get theta in a way by itself, and so I'm going to. Yeah, so I'm going to do a little substitution here and rewrite sy as gt squared minus 1/2 gt squared. So sy equals 1/2 gt squared. That seems kind of strange. Hold on. Yeah, that makes sense. Very strange, right? Okay. No, it shouldn't, it seems too pretty. No, it just seems too pretty. Okay, well, let's go with it and see if it gets uglier. You sure it will? Yeah. I'm sure it will too. All right, so now I'm going to, yeah, because that won't get rid of that. That in there. That just seems too pretty. Okay, so let's do this. I'm gonna skip. No, that's gotta be right. Yeah. Okay. Show that equals using this one. Let's see. That equals, so we can say that S of x equals 4.25 times 1/2 gt squared. Right? So, come on. Yes. Okay. That's what we said SY equals. Yeah. Uh-huh. Now he was showing me. Did you take out the point? Yeah, I saw that earlier. I was gonna comment. I like it. Problem is we're not getting any smaller here. Okay, I'm gonna hit a different approach. I think that's a blind alley. So I'm gonna take and solve S of X for T. But I think we're heading down a blind alley here. I know. You want me to make it worth more? Okay. We're gonna get the answer. 1,000 points. You know what? We're gonna continue this, but we're gonna set this equal to our VI cosine theta t. And we're going to solve that for, so that we'll get rid of a t on each side, right? So let's do this. Let's bring this out. 2.125 gt equals VI cosine theta. So t equals VI cosine theta over 2.125 g. Make sure I didn't screw anything up there. Right? Following along? So because I want to get, I really want to get rid of this t, I want to go back up here to my s sub y, or maybe even into something else, and get rid of the t. Oh, what if that's where I'm going to go. I'm going to substitute this. Oh, I'm going to substitute it into my vy. Yeah. I did that, and it's to be left with. See, I'm trying to get it so that I only have. So I get rid of some of the garbage in here. Huh? Yeah, that's what I'm trying to. That's where I'm mentally looking at this going. That's where I was looking at. I was looking at it and say, hey, can we go back up to here now and substitute in for t there? And if we do that, we get VI sine theta equals g times VI cosine theta. Oh, this is going to be pretty. 2.125 g. And now, VI's are gone, G's are gone. I'm left with tan theta equals 1 over 2.125. Theta equals. Moment of truth. Oh, it'd always be in the direction. Remember, that's one of the things about acceleration. It's in the direction of motion, it changes the speed. If it's tangential to motion, it changes the direction. If it's both, it changes both. It's kind of one of those G ideas. So, what is the centripetal acceleration component? All right. So, of course, towards the center of curvature, right? You guys all know that. This is number 9. B, I'm using the idea that acceleration centripetal is v squared over r. For me, my v is 3.00 meters per second. I square that. Mine is going around a radius of 10 meters. And I find my acceleration centripetal. Good on B? Yep. Determine the magnitude and direction of the total acceleration. I really gave you this. Well, I'm picturing that it's at the very top. So it's tangential, which for me was 0.7 meters, is in that direction. It's centripetal, I'm going to draw tip to tail, is in that direction. It's whatever my value there was. I've got that. Let me see. Direction. I'm going to assume that directionality-wise, it's going to, oh yeah, the car is heading in that direction, so let's take it as that. And this would be my A. So it would be, you know, Pythagoras there. Right? And I should try that and see if it's there or if they want it. The next thing is they didn't tell you the direction, a reference for the direction. You know? So let's see what mine comes out. So mine should be 0.9 here. Good. So no, I figured you guys know how to do Pythagoras in your sleep, right? C basically, let me just hit C basically, I am doing Pythagoras here. And so I'm going to do, for my angle, I'm going to do the inverse tan opposite my 0.9 over my adjacent 0.7. This is what I want to check. I knew all those things were fine. This should be 52.1. Yeah. So they did want the directionality as compared to the direction the car was going. So the car is in the same direction as that tangential acceleration, and the direction that they wanted for the acceleration was in reference to that. If they had asked for it within for the radius, it just would have been the other, was it complementary or supplementary angle? Complementary angle.